Hi, I'm Tim McMurray. Today I'm going to be talking about manufacturing methods and models. The first method I want to talk about is progressive stamping, a method widely used in high-volume manufacturing, or when you need a lot of something. Progressive stamping is a process where a long coiled strip of metal moves through a series of stations, each one assigned to a specific operation, like cutting, bending, or punching. As the metal strip passes through these stations, the part begins to take shape and eventually becomes a complete, precise part. Why is progressive stamping so popular? The answer lies in its efficiency and accuracy. By automating multiple operations in a single run, progressive stamping can produce parts quickly and accurately with minimal material waste. For industries like automotive, electronics, and appliance manufacturing, where they require massive quantities of identical parts, stamping is incredibly cost-effective. One of the biggest strengths of progressive stamping is its speed and repeatability, which means each part is nearly identical to the last. Plus, it can handle complex geometries, allowing manufacturers to make intricate shapes. However, there are a few limitations. One major challenge is the non-recurring engineering cost, or the cost of creating the punches and dies. Also, once these punches and dies are made, they're not easy to alter, so any design changes later on can be extremely expensive. The main reason progressive stamping is one of my favorites is my first job was an internship in quality assurance at a stamping shop. There was one part there that always intrigued me. It was the EKG buttons you see below, that little metal clip for the wires to hook up to the machine at the hospital on the pad. The press that made those ran at 800 strokes per minute, and with each stroke, the press made 6 parts. We were able to keep that press running about 80% of the time, and the shop ran 24 hours a day, 6 days a week, for 50 weeks a year. Now, if you do the math on that, that's 5.5 million parts per day, or 1.7 billion parts annually. Those numbers blew my mind. Billion with a B. Next, we have photochemical machining, or PCM. PCM is an etching process that uses light-sensitive chemicals, or photoresist, to create detailed patterns in metal. To start, a photoresist is applied to a metal sheet and exposed to UV light through a pattern. This exposure defines the areas to be etched away, while the remaining metal covered by the mask forms the part. PCM is particularly valuable in industries like electronics, aerospace, and medical devices, where precision and detail are crucial. Components such as circuit boards, intricate filters, and other small metal parts benefit from PCM's ability to create complex geometries without introducing any mechanical stresses. Unlike traditional machining, which can bend or stress delicate materials, PCM is a non-contact process that works gently even on fragile materials. The greatest strength of PCM is its precision, especially for fine features and thin materials. However, it's best suited to thin sheets, usually below 0.5 millimeter in thickness, and it's slower than other methods for large-scale production. It's also more costly for high volumes, so it's not as economical for mass production as some other techniques. To summarize, photochemical machining is ideal for applications needing high precision, intricate details, and stress-free processing through its use of thin materials and relatively slower speed in its applications. It remains a valuable method when precision and detail are key. Now let's look at gear hobbing, a highly efficient way of manufacturing gears. In this process, a cutting tool, called a hob, shapes a blank gear, cutting teeth at precise angles. This rotational cutting method is perfect for producing various types of gears, including spur, helical, and worm gears. Industries like automotive, aerospace, and heavy machinery rely heavily on gear hobbing for its ability to produce gears with tight tolerances quickly. These gears are essential in engines, transmissions, and industrial equipment. Hobbing ensures that gears meet stringent quality requirements, as gear functionality depends on precise dimensions and alignment. The biggest advantage of gear hobbing is its productivity. It's capable of producing large quantities of gears with consistent accuracy, especially in automated settings. However, it has its limitations. While it's great for small to medium-sized gears, very large gears require different methods. Also, gear hobbing requires specialized tools for different gear types, which adds to production costs. In short, gear hobbing is a cornerstone of precision manufacturing for high-quality gears in various industries. Its high productivity and accuracy make it an essential process, though it does come with its limitations related to size and tool costs. This is my favorite gear, and I feel like as a mechanical engineer, you need to have a favorite gear. This one is mine. This is the reduction gear in the Iowa-class battleships built in World War II. The reason this gear just blows my mind is, number one, its scale. You can see the worker standing next to it. He is barely a quarter of the height of this gear. And number two, these guys figured all this stuff out before calculators, before computers. They had calculated involute gear profiles and machined them with remarkable precision, all with pencils, papers, slide rules, and drafting tables. It blows my mind, and this is my favorite gear. Selective laser sintering, or SLS, metal 3D printing is transforming how we think about manufacturing metal parts. In this process, a laser selectively fuses powdered metal layer by layer, building complex parts based on a digital design. The result is a highly precise, strong metal component with minimal waste. SLS metal 3D printing has revolutionized industries like aerospace, automotive, and healthcare. For examples, companies can create lightweight, customized parts for airplanes, reducing fuel consumption and enhancing performance. In healthcare, custom implants are possible, tailored exactly to a patient's anatomy. What makes SLS special is its ability to produce complex shapes and fine details that would be challenging or downright impossible with traditional machining methods. The main strength of SLS 3D printing is flexibility. Manufacturers can create prototypes and final parts directly from a 3D model without needing molds or dies, allowing for rapid prototyping. However, it's not without its challenges. The equipment and materials are expensive, and the printed parts often need post-processing to achieve a smooth surface finish. Additionally, the production time for large parts can be long. In summary, SLS metal 3D printing offers unprecedented flexibility and design freedom, especially for complex parts. While cost and finish limitations exist, its benefit make it a key player in modern manufacturing, especially for customized, high-performance applications. Finally, let's discuss the Kano model. The Kano model is a tool for understanding customer satisfaction, developed by Dr. Noriki Kano. This model helps businesses classify product features based on how they impact customer happiness. These categories include basic needs, performance features, excitement features, each influencing satisfaction differently. The Kano model is used across industries from product design to service delivery. For example, in tech, a smartphone's battery life might be a basic need, while a high-quality camera could be a performance feature. And innovative features like facial recognition add excitement. By identifying these categories, companies can prioritize features that maximize satisfaction while avoiding resources spent on unnecessary features. The strength of the Kano model is its insight into customer priorities. By identifying what delights or disappoints, it helps businesses design products that resonate with customers and stand out from their competitors. However, a limitation is that the model relies on thorough customer research, which can be time-consuming and may not account for rapid changes in customer preferences. In conclusion, the Kano model provides valuable guidance for product development by focusing on customer needs. While it requires investment in research, it helps companies create products that are more likely to satisfy and retain their customers. Thank you for listening to me.